To understand pulse width modulation, we need to first understand the difference between an analog and a digital circuit. Here on our breadboard, we've got two independent circuits going on. One is an analog circuit with a yellow LED, a resistor, and a potentiometer. The circuit is connected to a 3-volt battery supply. While at the bottom, we have another independent circuit with a blue LED, a resistor, and another 3-volt battery supply. And this circuit is connected to a switch which can turn the LED on or off. The brightness of the yellow LED in the analog circuit can be varied by turning the potentiometer. So we can make it as dim as we like. We can bring it to 75% of the brightness, 25% of the brightness in a smooth fashion. While the blue LED on the left with the switch can be either turned on or off. So it can have just two values, on or off. Now, if I were to turn it on and off 100 times in a second, my eye wouldn't be able to see it blinking. Instead, it'll appear to be dimly lit. This can be achieved by PWM with a microprocessor or a microcontroller. So here is the schematics. Any pin marked as GPIO can be used for software PWM. I have used pin number 12 on Pi. So I have connected pin number 12 to the long leg of the LED, and I have also used a 220 ohms resistor. So let's get onto our code now. The very first statement is to import rpi.gpio library, and then next we import time, and then statement number 4 is gpio.setMode. We set the mode to board. And then on line number 5, we have our setup statement where we set up the GPIO pin. So our LED is wired to pin number 12 on Raspberry Pi. So that's the pin we need to set up. And LED is an output device. So we set up pin number 12 as an output pin. Next, on statement number 6, we have created an object called LED1 of class PWM. Now there are two parameters here in PWM. The first one is the pin number, so we give that as 12, and the second is the frequency. Frequency is the number of cycles per second. So one on and off signal together form one cycle. So here the number 100 would mean that we are going to turn on our LED 100 times and turn it off 100 times in 1 second. Now on line number 7 is the start function from PWM. Here the number is the duty cycle. Duty cycle is the duration of on signal in each cycle. Now here the number 20 would mean that LED is turned on for 20% of the time in each cycle. Now if we want our LED to light up at 50% of the brightness, we would make this number as 50. Now let's do a little experiment with duty cycle and frequency and understand what they do. Let's delete the rest of the code for now. So let's go to line number 6 now and play around with the frequency. Let's change this frequency from 100 to 10 and see what happens. There, we can see the LED flickering. It flickers 10 times in a second. Now let's change this frequency to 25. And now it's going to go on and off 25 times in a second. Now let's increase the frequency to 50. And let's run it. Their signal is much smoother now. We cannot see it flickering. It still goes on and off 50 times in a second, but it's too quick for us to see.
So now let's change the frequency to 100. That's the maximum value. And let's run it. And there you see LED lit up all the time. The LED still goes on and off 100 times a second, but it's a smooth signal. We don't see it flickering. So now let's take a look at the duty cycle on line number 7. Right now, duty cycle is at 50. So duty cycle can be between 0 and 100. Right now it's at 50. That means the LED is going to be lit up at 50% of its full brightness. Now let's go and change it to 20 and see what happens. And there, it's much dimmer now. It's lit up at 20% of its full brightness. Now, let's start with 20% duty cycle and then let it sleep for 1 second, and let's change the duty cycle to 75% after that. So now we are going to see our LED being lit up at 20% of its brightness for a second, and then it brightens up to 75%. Now, let's increase the brightness of our LED gradually in a loop. So for DC in range, let's get a for loop here. Let's get the change duty cycle inside the loop. And we'll get a short time interval inside the loop. So it's going to change duty cycle in every 0.1 second. And let's start with 0 duty cycle. So it's going to start with 0 brightness. Let's run this code. So it's going to start with off, and then it brightens to 100%. And now let's shorten the time duration within the loop. Let's make it 0.01, and we'll see it brightening faster. There. And that's how PWM works. So there are 2 parameters we need to take care of when using PWM. It's frequency and duty cycle. And with this, we can run a servo motor, DC motor, or we can change the brightness of an LED.